Understanding Satellite Images, and our speaker is Meghna. Meghna is a PhD researcher at the University of York and a DSSG Fellow at the Alan Turing Institute. She has a passion for her research in computer vision and deep learning. She possesses 7+ years of experience in Python programming and computational mathematics. She's keen on talking about satellite imaging. I can't wait. This sounds awesome.
Okay, so I'll
Yeah.
start and share my screen. Yeah.
Yep.
Right. So let's. Can everyone hear me now? Hello.
Yeah, we can hear you, Meghna.
Hear
Go
you.
ahead.
Okay, that's fine. Thank you. Okay, so I'll start by introducing myself, as already been said by my friend over here. I'm a PhD researcher and a fellow, and today I'm just going to talk about satellite imaging. So let's start by looking at what we are going to talk about. So the table of content talks about the introduction. So what is Earth observation? The second thing is the data that we use during satellite imaging. And third is the tool that we tend to use while accessing those types of data sets, because it's very different from normal tabular data sets. And the third are some computer vision methods that are generally used during assessing these images. And we are also going to look at a case study which would help us understand the application of these kinds of methods, um, and finally the conclusion. So let's start with the introduction. So what is Earth observation? Basically, Earth observation is just collecting and gathering information about planet Earth in its physical, chemical, or biological system via remote sensing technologies. These can be satellites, these can be um, just images, anything that you can get, or these could be LiDAR images, which is like the laser thrown on the surface of the Earth, or just RGB images. It is crucial because it is for long-term monitoring of very inaccessible areas of the world, say like very remote islands in the Pacific. And it is also very useful when you know there's a natural disaster about to happen, and it helps in safe evacuation for plans for the government. The next thing is the types of things that we can predict using satellite data. These are the very obvious ones that I'm going to just throw out some pictures for you. So these can be flooding, earthquake, landslides, wildfire, dam breaking, and volcanic activities. And these are basically time series. So you take data from, say, the first day of the year to the last day of the year, and you see whether the water level has risen, or there's any change in the tectonic plates, or is the number of trees in a region have gone down. So that's how you assess like what is happening. But there are a different type of analysis that you can do from these data, and that is like precision farming. So like just try to improve the productivity of a land area, the number of crops that are produced from an area, pollution modeling, also crime patterns in a city or a country, forensics, GIS, and just like anything that is not out of the box. So let's move on to the type of data that we have. The first type of data is vectors. So these vectors are just points on points like X and Y coordinates on the latitude and longitudinal scales that you are working on. There are very different types of uh, longitude and latitude standards that we use. And the next one is the raster image, which is an RGB image, and it is able to hold a lot of information as compared to the vector images. So that's the two type that we are going to use. um, let's now talk about some tools that we go for. For the desktop software, just to analyze and look at some images, we use QGIS, which is an open source platform, and the full form of QGIS, Quantum Geographic Information System, and it allows us to create, edit, visualize, and analyze the published geospatial information, which can be from the Copernicus satellite data constellation. Very simply used ones are Landsat and Sentinel-2. In terms of programming softwares that we could use, we have Python especially, and in those we have GeoPandas, which is very similar to Pandas. If you're familiar with it, it's very easy to go onto GeoPandas, Raster.io, and especially R. You can also use that in terms of programming. So the case study that we are going to look at is the net zero strategy to bring back greener from the UK government. So the net zero strategy sets out on how UK will deliver on its commitment to reach net zero emission by 2050 and reduce Britain's reliance on imported fossil fuels, and would also help in reducing the global climate changes that is happening. And so what we are trying to do using satellite imaging is trying to switch from non-electric to electric sources for heating for individual houses. And what we can do is install solar panels for it. And using satellite imagery, what we're going to do is try to identify individual houses which are solar panel installation ready. And hopefully with this insight in mind, we are able to give insights to the decision makers in the counties and the government so they can create the right decision. Next one is, let's talk about some methods. So first one is the satellite image segmentation. So I'll not go much into detail about the type of the network that there is, because there's a lot of layers going on. So I'll just speak in terms of a very basic way. So SegNet is a semantic segmentation model, as you can see from the image down below. So the first one is, the top one is our normal image of a city where you have cars, buildings, and the road and the sky. And you can see that each different type of category is divided into different colors. So the roads are purple, cars are indigo, buildings are red, vegetation is yellow, sky is gray, and the people are in green. So this is how the segmentation network works. And UNet is another way of doing this. So in the same way, we do it for some satellite imaging. So you can see in the images over here, you have vegetation in dark green, the ground in light green, roads in gray, and the buildings in black, and water in blue. So that's how we segment and try to interact with each object on its own. So example from the case study is like, what we are trying to do is we are trying to calculate the area of a house in order to understand whether it is a good candidate for solar panel ready. So what we try to do is we get the raw image, RGB image of a house. We create a bounding box mask over each building, and using our coordinate system in which we reside, we predict the area of the building, the roof, in meters square. So these small numbers that you can see is the building area we have just calculated from the satellite images. So that is the example from the case study. The second thing that we can do is feature detection. A very famous example of feature detection or object detection task module is VGG16. So it has been a very highly used model in computer vision. It has been done on ImageNet dataset, which has over 14 million images, which belong to 1,000 classes. And this is a complex structure of the the VGG16 model, which I'm not going to go in detail. And let's go on to the example. So this is like images of a satellite data from a glacier. So what you can see is the blue part is the water, and the white part is the glacier, and we can see the change in glacier that is coming. The drawback from this network is that it is very slow to train, but we can get rid of that by using pre-trained models. That is what we generally tend to do using PyTorch or TensorFlow kernels. Another object detection module is Resnet Module. It is very similar to VGG16, but it has been faster and has low complexity, and it is easy to optimize. From the example, I would like to show you an identification of tulip fields in Netherlands. So in the first one, you can't see any tulip fields, so you get a black mask because there are no tulip fields. And in the second image, we have tulip fields, and these are which can be mapped out in white. So example from the case study. So we are trying to detect solar panels on the roof of individual houses. So for that, first we do is building detection. So on each image, the image on the very left-hand side, you see the RGB image. The second one is the ground truth that we already have. And the third one is the prediction that we do from our object detection softwares, algorithms like VGG16 or Resnet. And on the very right-hand side is a plot of actual number of buildings there and the predicted number of buildings in an image. And we see that it's quite a good correlation. Whereas when we come to the panel roof detection, we have this very slight black thing over a house is the ground truth, is basically the solar panel that we are trying to detect. So the ground truth is over here, and the last part is the prediction. And what we do tend to see is that it tends to give a lot of false positives, as can be seen from the graph on the right, that the actual number of panels and predicted panels, that it predicts a lot more. So there are a lot of false positives. So this is something that we need to really work on in our case study, that we are still really trying to get around. So conclusion, yeah. So in this talk, we talked about Earth observation and what exactly it is, and the data and tools which we could use and which are available for us for free. And the methods that we talked about are image segmentation and detection, which could be used to calculate floor area and solar panel detection. And we talked about the case study on solar power potential in the UK. Thank you. And if you have any questions, please reach out to me at meghna@york.ac.uk. And you can also add me on LinkedIn using this QR code.
Thank you, Meghna. That was awesome. So if you guys have any questions, you can leave it in the chat over here. I'll read them out to Meghna and she can answer them for you.
Should I keep my slides on?
Yeah, you can keep it going. If there's anyone who would want to scan it later on and write it down, write down the email ID, it would help.
Okay.
Yeah. So I have a question. So you mentioned different libraries like PyTorch and TensorFlow. Which one do you think would be better for a particular type of a model, for example?
For a particular type of a pre-trained model, I would definitely
Yeah.
go for PyTorch, because TensorFlow does not have a level of abstraction that PyTorch provides. TensorFlow does have Keras, but it is personally, from my experience, I definitely prefer PyTorch, and also it is very great when you are working with a debugger. Like in TensorFlow, you can't really debug your TensorFlow models, but you can do that using PyTorch models. So that is a very useful thing. So I would definitely go for
Um,
PyTorch.
okay. Another question: how can one start with basic satellite images from open source, for example?
Right. So this was a quite a big learning curve for me as well. So what I tried to do was I just went on Copernicus.eu, which is the European Space Agency open source satellite data, and I just went on it and looked at some tutorials on YouTube. There are a lot of them, and then I download different areas that of interest for me, and you can download it for a resolution of 10 meter by 10 meter, 20 meter by 20 meter, and 60 meter by 60 meter. And these can give you these are downloads which are free, and you can download as much as you want. So there's a lot of data that you can play with, and then you open it in QGIS, and which is also again an open source platform. You can do it for free, and then you can play around with it using some PyTorch tools inside QGIS, or write your own scripts on Python, Jupyter Notebook, whichever is useful for you. So that's how you can get started.
Um, that's really interesting. I'm definitely going to check that out.
Right.
What are some of the best platforms to analyze satellite images?
I would definitely go for QGIS. That's the best way to go.
Okay.
um, for someone who does not want to pay. But for like if you have a university account, and probably your university has ArcGIS for their like all the tools that they have purchased, then definitely go for ArcGIS. But if someone is just starting out and is not affiliated with any university who has access to ArcGIS, then definitely go for QGIS.
Okay. Yeah, I had one last question. So, what information can you get from satellite images other than the geospatial location?
Like in terms of if you collect enough images of a city or like a place, um, and you can create a time series model out of it, you can see the changes happening over over a period of time. So you can predict like whether there's going to be an earthquake or landslide. So it's just not just a spatial thing, it's a temporal thing as well. Definitely, there are much more modules that come with it. But yes, you can definitely go for the temporal aspect as well when you become more adept with the spatial part of it, because even the spatial part has a big learning curve to understand for anyone.
Okay. Thank you so much.